Hi listeners, you are welcome to the continuation of our online tutorial physics class from your favorite student ScoreBooster, your online tutorial provider on WAEC, JAMB, NECO and NAPTIP exam. For today's presentation, we shall be discussing the concept of Boyle's law. I am Bangbade AA. Before we proceed, we need to consider the learning outcome of this particular presentation, which goes thus. At the end of this presentation, listeners should be able to state Boyle's law. They should also be able to state the mathematical expression for Boyle's law. And lastly, they should be able to interpret the graphical representation of Boyle's law as well as solving relevant UTME questions relating to Boyle's law. Now on to Boyle's law. Boyle's law states that for a fixed mass of gas at constant temperature, the pressure P is inversely proportional to the volume. I repeat, Boyle's law states that for a fixed mass of a gas at constant temperature, the pressure P of the gas is inversely proportional to the volume phi. Mathematically, pressure P is proportional to 1 over phi. Then when we introduce constant of proportionality, that will give us P equals K over phi. Then we can cross multiply to get K equals P phi. K here is the constant of proportionality, phi is the pressure, while phi is the volume. It is very important to note that the constant here, which is equal to P phi, can be equivalent to work done or energy. From the units, pressure is Newton per meter square, then multiply by volume whose unit is meter cube. If you multiply Newton per meter square by meter cube, it will give us Newton meter, which is equivalent to force times distance, which can be used to calculate work done or energy. You have to recollect that from our video 1 and 2 on Newton's law of motion and forces. Now, since we've derived that constant of proportionality here equals P phi, then whenever we have more than one pressure and one volume, then our constant of proportionality for the volume 1 and pressure 1 will be given as K1 equals phi1 P1. Then that of volume 2 and pressure 2 will be given as K2 equals phi2 P2. K2 in this case is the constant of proportionality for the new or final one. Phi2 will be the final volume of the gas, while P2 is the final pressure of the gas. Phi1 is the initial volume of the gas, while P1 is the initial pressure of the gas. Then, since K1 and K2 are constant, if K1 is equal to K2, then we arrive at phi1 P1 equals phi2 P2. So this formula is very important for calculations under the Boyle's law. Phi1 P1 equals phi2 P2. So you have to take note of this because it is what will be applying under the calculation of Boyle's law. I repeat, phi1 P1 equals phi2 P2. It is worthy of consideration. Now on to graphical representation of Boyle's law. And the first graph we have in here, which is label 1, is the graph of volume phi against pressure P. which is usually a curve. So when the volume phi is plotted against pressure P, we have a curve. While the diagram label 2 is showing the graphical representation of phi against 1 over P. So if phi is plotted against 1 over P, we have a straight line graph. Similarly, diagram 3 is showing the graph of P against 1 over phi, which is also a straight line. So when pressure P is plotted against 1 over phi, we have a straight line graph also. Now on to sample questions. The first question we shall be considering comes from 1999, number 10. And the question goes thus: a gas at a volume phi naught in a container at pressure P naught is compressed to 1/5 of its initial volume. What will be its pressure if it maintains its original temperature T? Now, we are given option A to be P naught over 5. Option B is 4P naught over 5. Option C is P naught. Option D is 5P naught. Now on to solution. So we're told here that the initial volume phi I is represented by phi naught, and the initial pressure P1 is represented by P naught. Then also that our final volume is 1 over 5 of the initial volume, which means phi2, final volume phi2 equals 0.2 of phi naught. Since our phi1 is phi naught, then 1 over 5 is 0.2, therefore phi2 will be equal to 0.2 phi naught, while the pressure P2 is unknown. Then using the formula for Boyle's law, which is phi1 P1 equals P2 over phi2. When we substitute our phi1 in this case is phi naught times P1, which is P naught, equals phi2, which is 0.2 phi naught, then times P2, which is unknown. Then we can make P2 the subject by dividing both sides by 0.2 phi naught, and that will give us phi naught times P naught over 0.2 phi naught equals P2. Then we can cut phi naught off, so that we'll be left with P2 equals P naught over 0.2, and this will give us 5P naught. When we multiply both numerator and denominator by 10, it will give us 10 over 2 P naught. Then 10 over 2 is 5. So our P2 will be equal to 5P naught, making option D the correct answer for this particular topic. But we have a shorter method of solving this by applying the principle of Boyle's law. Since the volume is inversely proportional to the pressure, that means the higher the volume, the lower the pressure, and vice versa. So as volume is increasing, the pressure will be reducing. When pressure is increasing, the volume will be reducing. So in the case of this particular question, since they said the pressure is the volume is reduced to 1/5 of initial volume. So if the volume is reduced by 1/5, that means the pressure will be multiplied by 5, since it's inverse proportionality. So, and since the initial pressure is P naught, when the volume is reduced to 1/5, then the pressure will be increased to 5 times initial pressure, and 5 times initial pressure will be 5 times P naught, which will give us 5P naught, making option D the correct answer for this particular question. Now the next question we want to be considering comes from UTME 2013, number 18, and the question goes thus: a gas at a pressure of 10 raised to power 5 Newton per meter square expands from 0.6 meter cube to 1.2 meter cube at constant temperature. The work done is dash. Then we have option A here to be 7.0 times 10 raised to power 6 joule, Option B is 6.0 times 10 raised to the power 6 joule. Option C is 6.0 times 10 raised to the power 5 joule, while option D is 6.0 times 10 raised to the power 4 joule. Now to solution. We're given the pressure P to be 10 raised to the power 5 Newton per meter square. I repeat, the pressure P is given to be 10 raised to the power 5 Newton per meter square. The volume here will be the change in volume. That is the difference between the final volume and initial volume. And that will give us the final volume, which is 1.2 minus initial, which is 0.6. That will give us 0.6 meter cube, representing the change in volume. Then we have to record that we said the constant of proportionality in Boyle's law, K, is equal to P times phi, and that it can be equivalent to work done as proved in the earlier part of this presentation. Therefore, our work done here will be equal to K, which is equal to P phi. And when we substitute, our P is 10 raised to the power 5 Newton per meter square times 0.6 meter cube, which is our volume. So if we solve this, we are going to have 6 times 10 raised to the power 4 joule, making option D the correct answer for this particular question. Now the next question we shall be considering comes from WASC 1996 number 15, and the question goes thus: the pressure of a fixed mass of gas is 2.0 times 10 raised to the power 5 Newton per meter square at a known temperature. Assuming the temperature remains constant, what will be the pressure of the gas if the volume is halved? Then we have option A to be 1.0 times 10 raised to the power 5 Newton per meter square. Option B to be 2.0 times 10 raised to the power 5 Newton per meter square. Option C is 3.0 times 10 raised to the power 5 Newton per meter square. Option D is 4.0 times 10 raised to the power 5 Newton per meter square, while option E is 5.0 times 10 raised to the power 5 Newton per meter square. Now on to solution. The initial pressure P1 is given to be 2.0 times 10 raised to the power 5, while the final pressure P2 is unknown. Then also from the question, we were told that the final volume is half of initial volume, since they said the volume is halved. So therefore our final volume phi2 will be 0.5 of phi1, 0.5 phi1. So we have to record that using the formula for Boyle's law, which is phi1 p1 equals phi2 p2, then we can substitute, our phi1 times phi1, which is 2.0 times 10 to the power 5, will be equal to phi2, which is 0.5 phi1 times p2, which is unknown. So we can make p2 the subject by dividing both sides by 0.5 phi1, and that will give us phi1 times 2.0 times 10 to the power 5 divided by 0.5 phi1 equals phi2. Then phi1 will cut phi1. I will be left with phi2 equals 2.0 times 10 to the power 5 divided by 0.5, and that will give us phi2 equals 4.0 times 10 raised to the power 5 Newton per meter square, making option D the correct answer for this particular question. Now on to practice questions, and the first question here for your practice goes thus: the volume of a fixed mass of gas was 300 cm3 at a known temperature. What will be its new volume if its pressure is tripled, provided the temperature is kept constant? Option A here is 900 cm3, option B is 600 cm3, option C is 100 cm3, option D is 300 cm3. The hint to answer this is that you have to record that P is inversely proportional to phi. That is, the higher the pressure, the lower the volume, and also the higher the volume, the lower the pressure, and vice versa. Expected answer here is 100 cm cube, which is option C. And the second question here for your practice goes thus: the volume of a fixed mass of gas at 200 atmosphere and 300 Kelvin was 100 cm cube. What will be its volume if the pressure is reduced to 1/4 of its initial volume, provided the temperature is constant? You have option A here to be 100 cm cube, option B is 400 cm cube, option C is 25 cm cube, while option D is 50 cm cube. You are also to use the same hint that P is inversely proportional to V, and the expected answer here is 400 cm cube, which is option B. Now, our next video will be on Charles' law with sample questions and solution. I urge you to please subscribe to our YouTube channel, like and share our videos, as we promise to be providing you with more interesting lectures on subjects related to UTME and SSC. Thank you.